Dale takes the stage, I want to introduce Julie G. Alzheimer's is a very personal issue for most of us. With Julie, it's even more personal. She's going to tell you her story. She's a founding member of a group of people who are very personally invested in finding cures and preventions for this disease, and it's a perfect kickoff for this event. So Julie, it's off to you.
Good morning. Let me start by thanking Dr. Bredesen and everyone here at the Buck who made this event possible. We're humbled and honored by all you're doing for us. Thank you. I'm here today with an incredibly courageous group of ApoE4 carriers. Please stand if you'd like to be recognized. Today is a very emotional day for us. We've been an important source of cyber support to one another for several years, and we're meeting today face-to-face for the first time. These brave folks all learned their ApoE4 status through different means, many through 23andMe, and some through their cardiologist without even their consent. The vast... Can you hear me? Okay. The vast majority of us had never heard of this protein, ApoE4, prior to learning of our own status. Many of us, the homozygotes especially, were traumatized. Homozygotes are folks who carry 2 copies of the E4 allele. It's been a life-changing experience for all of us, and I think it's safe to say that we're all in varying degrees of recovery since learning this information. It's been widely reported that James Watson, the co-discoverer of DNA itself, had his own genome sequenced, with the exception of one gene. Dr. Watson chose not to learn his ApoE status, knowing that he could be the carrier of a gene that greatly predisposed him to Alzheimer's disease, a progressive, incurable, fatal neurodegenerative disease with no known treatment or prevention was more than he could bear. Yet that is precisely the knowledge that we're forced to live with every single day of our lives. No wonder many of us were terrified when we turned out. Through forums provided by 23andMe, we banded together for support, and our international cyber family was formed. After reeling from the shock, one of our first orders of business was to try to determine prevention strategies in terms of diet and lifestyle choices. Okay, you have our attention. We have a really sucky gene that not only leads to Alzheimer's disease, but also heart disease. We're ready to get very compliant. Imagine our shock upon learning there really wasn't a prevention strategy, much less one geared specifically to E4 carriers. Instead, we were provided with platitudes. We were told to eat right, to exercise, to engage in hobbies like square dancing, to stay social and do puzzles. Really, my life is on the line, and the best the medical community can come up with is puzzles. We not only needed support, we needed evidence-based, actionable information. We branched off from 23andMe in an effort to stay more organized, and ApoE4.info was born. We currently have around 200 members. Today, I'm going to share a little bit of my personal journey with you. Keep in mind, it's just one story among many. The knowledge of learning I was an ApoE4 homozygote was particularly traumatic, as I was exhibiting symptoms of cognitive decline when I learned my status. I was young. I was 49 years old, and Alzheimer's was the furthest thing from my mind. My overall health had been declining despite my doing everything I knew to lead a healthful lifestyle. The most terrifying of all my symptoms was a subtle and progressive change in my cognitive functioning. One of my first clues that I might have a problem occurred as I was driving home one day. I was on a very familiar road, one that I'd taken thousands of times before in a city where I had lived for 20 years. Suddenly, for just a few seconds, I looked around and I had absolutely no idea where I was. It passed, but this feeling of being lost would occasionally reoccur without warning. I was terrified. Several times around town, I began to have encounters with people who would come up to me. They seemed to know me very well, and I had absolutely no idea of who they were. They would begin speaking about their families and my family. I knew I was supposed to know them, but I didn't. I fumbled my way through those conversations. I realized I was in trouble. Another change was more insidious. I had been an avid reader my whole life, reading 2 to 3 books a week. And slowly, over time, I stopped reading as much. I had a hard time hanging on to the plot, the characters, the sentence I had just read. Reading for pleasure was no longer pleasurable. My husband is an airline pilot. He was flying internationally at the time, and he'd be away from home for 7 to 8 days at a shot. Looking back, he now expresses shock at how much I would have declined even the short week he was gone away from home. He reports that I would often walk away mid-conversation, frustrated because I couldn't find the words I was searching for. When I finally revealed to him that I thought I might be exhibiting early symptoms of Alzheimer's disease, rather than give me the reassurance I was so desperately searching for, he said, "Well, that explains a lot." Learning and remembering had always been relatively easy for me. I had earned straight A's in my graduate program focusing on marriage and family therapy. These cognitive problems were new for me. I decided it'd be helpful to quantify them, so I signed up for an online brain training and assessment program. Despite giving it my best effort, my initial scores were in the mid-30th percentile for my age group. I had ample proof that my problems were real. Frighteningly, around this time, I learned that my cousin had just been officially diagnosed with Alzheimer's disease, late onset Alzheimer's disease. Many of the women in his side of the family developed Alzheimer's as they went into their 70s and 80s. His doctors verified that he had high levels of tau protein in his cerebral spinal fluid. My cousin was 49 years old. I had read that ApoE4 carriers developed symptoms earlier. I now saw it in my own family. When I began to comprehend that Alzheimer's was progressive, untreatable, and incurable, this was 3 years ago, the idea of taking my own life occurred to me. The concept of living with Alzheimer's, knowing what I and my family would be facing, was incomprehensibly devastating. I eventually had a strong desire to move back to my roots, to the shores of Lake Michigan, back to my extended family, whom I was equally terrified for. My husband and I left our home in the South where we'd raised our son, and I moved back to where I'd grown up to essentially die. I didn't tell anyone. I also didn't tell anyone another hope one that I harbored deep in my heart, a hope that I could figure this out, that I could heal, that I could live. Around this time, I was connecting with other E4 carriers from all over the world who were grappling with the same terror and had the same questions. What should we be eating? Does diet even matter? High fat or low fat? Fish oil or no fish oil? The research was scarce and often contradictory. What seemed to help other ApoE genotypes often didn't help our population. Any strategy we trialed ultimately turned us into modern-day canaries in the coal mine. We were blessed to have some scientists and physicians among us. Guess what? ApoE4 doesn't discriminate. The vast majority of us, however, were non-scientists. Despite this, we slogged our way through every single paper we could get our hands on, as if our life depended on it, and it did. Many of us had medical journals in one hand and medical dictionaries in the other hand. We read, we discussed, we debated. We kept this up for a period of years. And over time, many of us slowly began to make dietary and lifestyle changes based upon the information we were learning. I realized I needed to enlist the help of a neurologist. It took me several months before I felt strong enough. I wanted to be able to get through my appointment without breaking down in tears. I traveled to a nearby town to see the most esteemed specialist in my area. I trembled as I shared my story and my homozygote status with him. I asked him what I could do to prevent my symptoms from worsening, or better yet, reverse them. His response to me, good luck with that. I was crushed. I share that story with you to let you generally understand the quality of help that we're receiving from our local neurologist. Once this disease process begins, it's largely considered hopeless. Even in terms of prevention, the vast majority of neurologists are clueless. During this time period, I found a glimmer of hope on the internet. I stumbled upon an amazing lecture entitled Alzheimer's Can Be Prevented. It was given by Dr. David Perlmutter at NYU. As you can imagine, I listened more than once. I took rapid notes, and I began incorporating some of Dr. Perlmutter's strategies into those I'd already developed. I made an appointment to see him, and even though this was pre-brain grain, I still had to wait 6 months. During that interim, I continued to make changes based upon everything I was learning with my E4 brothers and sisters. I made sleep a priority. I worked hard to cut all toxins out of my life, even little things like the fluoride in my toothpaste, the aluminum in my deodorant. I tried to eat only organic foods. I cut out all sugars and refined carbs. I began tracking my glucose, my A1C, and my insulin. I began balancing my omega-6s and 3s. I started eating fermented food. Every bite of food that I took was specifically chosen to feed my brain. Food alone wasn't doing the trick. I began taking targeted supplements. Curcumin, in particular, made a noticeable difference. I made healing my full-time job. I prayed. I meditated. I alternated walking with running. Sometimes an hour or two a day. I challenged my brain as I exercised my body. Walking wasn't enough. I started counting backwards from 100 by 5s. That was pretty easy. Then I started doing it by 7s, 8s, 9s. As I walked along, I tried to recite the alphabet backwards. powerful was happening inside of me. With all of the changes I was implementing, I could actually feel my brain begin to heal. By the time I finally got to Dr. Perlmutter, I was substantially better. He helped me further hack my methylation by adding more B vitamins. He checked my heavy metals. He wanted my vitamin D level higher. Through serum testing, he revealed that I had a fairly acute sensitivity to gluten. I cut out all grains at that point and ultimately settled on a heavily plant-based diet. I eat a wide variety of colorful, non-starchy vegetables, some limited starchy vegetables, and wild berries. Just enough animal protein high in omega-3s. Dr. Perlmutter taught me not to fear healthy fats, a paradigm shift for me and tricky for E4 carriers, as we tend to have an exaggerated response to dietary fats. I safely began adding high polyphenol extra virgin olive oil, avocados, nuts, and seeds. As I incorporated Dr. Perlmutter's tweaks with my dietary changes, I began to heal even further. I was brain training religiously during this period, and my scores had slowly inched up from the mid-30th percentile to the high 90th percentile. I was regularly seeing scores of 98.9 to 99.9. I felt good, really good. By focusing on my brain health, all of my other odd and often debilitating medical symptoms melted away. I stand before you today feeling incredibly healthy, more stable, and better than I have at any other time in my adult life. Most importantly, I now have hope for a future. In October of last year, I got my hands on a compelling paper entitled Reversal from Cognitive Decline, a novel therapeutic program by Dr. Dale Bredesen. Wow. After closely following the Alzheimer's landscape for the past 3 years, I recognized what a big claim this was. I had seen single treatment modalities, primarily Big Pharma's anti-amyloid therapies, fail with alarming regularity. The idea that a well-respected researcher was claiming to have reversed cognitive decline, that was unheard of. Believe it or not, I was slightly skeptical, but very intrigued as I began to read his paper. And as I was going along, I got more and more excited. I began to realize that the strategies Dr. Bredesen was using were the same ones our group had been employing. By the time I got to page 7 of his paper, I almost fell out of my chair. He had an outline of all of his strategies. It was entitled Therapeutic Systems 1.0. And I went down the list going, check, I do that. Check, yeah, check, yep. I mean, he had a few new ones, but in my own primitive fashion, I had been following the vast majority over the past several years, and it worked for me, just like it did his other 9 case studies, half of whom were also E4 carriers. I immediately sent an email to Dr. Bredesen, and I think we spoke that same day. I was incredibly impressed with his individualized, multifactorial approach, but also by his kindness. As you can imagine, after the publication of this groundbreaking paper, he was inundated with hundreds and hundreds of emails like mine. But he actually took the time to reach out to me and our group, and we've stayed in touch ever since. Dr. Bredesen's paper validated my personal experience, a journey that I never fully acknowledged until I read his paper. And in a much smaller way, my personal experience validates Dr. Bredesen's approach. The rest is the beginning of history. Dr. Bredesen is extending his research by offering targeted members of our community the opportunity to use his protocol, which he will describe in much greater detail. Without further delay, I am so pleased to introduce the man who offers hope, Dr. Dale Bredesen.
You may have seen just a week ago in the New York Times, the last day of her life, which was a story about a woman who also developed Alzheimer's disease, and at 65 she had planned for years to commit suicide, and she on May 22nd of 2014 did that with the approval of her husband and with the approval of her family. All the stories we've heard about up till now end tragically. What you've heard today and what you'll be seeing today is the beginning of the happy endings to these same stories, and that is the future. And it takes activism, and it takes thought, and it takes coming out and talking about it to make this fundamental change in the way we think about this. So I call this dawn of the era of treatable Alzheimer's disease, because it is a time when we can look earlier and earlier. Until recently, as you know, we couldn't make the diagnosis until it was too late. Now what happens, we have the tools to see it earlier and earlier and earlier, and the genetics that Julie talked about as well, to know if there is a risk factor. So these are important. And by the way, Julie talked about ApoE4. As you probably know, many people have it without ApoE4. So if you have no copies of ApoE4, your chance of getting it during your lifetime is about 9%. So it's not zero. If you have one copy, it's about 30% or so. And if you have two copies, depending on the study you read, it's anywhere from 50 to 90%. So it's much more common. It's not 100%. So in fact, you can live, in fact, there are examples of centenarians who are ApoE4 homozygous who did not develop Alzheimer's. But as Julie indicated, once the symptoms begin, of course, that story changes. So absolutely, we want to be active, and we want to be active as early as possible. So if you go listen to television, Maria Shriver will tell us, and the experts will tell us, there's nothing that will prevent, reverse, or slow the progress of Alzheimer's disease. Well, I beg to differ with that. Things are changing rapidly. The other thing you often hear said is everyone knows someone who's a cancer survivor. No one knows an Alzheimer's survivor. Well, meet Julie G. She's someone who's changing things, and her group and her website. These are all things that are going to contribute to a fundamental change in what we do about this, the way we think about it, how early we get tested. All these things are changing. We are in a real era of upheaval. So for those of you who haven't seen patients, I want to show a couple quickly just to show the typical story here, and then I'll show you how we can change that. So this first person is a physician, and let me just play this for you.
You were diagnosed in 2005. So it's already almost 3 years ago.
That's right.
Yeah. What made you even go to a doctor?
I had an anger problem. My typical mild self to go over. My daughter had come to live with her kids with us. And it turned out that I just couldn't cope with the kids. I wasn't prepared to raise kids again, so it was natural for me to be angry. But my anger was out of control. I would really have spells of anger. And then the other thing that happened was that I was having spells, very briefly, of driving down a familiar street and suddenly being unable to remember where I was. I couldn't remember where I was supposed to be.
So you can see two things, and you heard from Julie before about the spatial memory, which is a very common problem, not present in everybody, but it's a very common one, and I'll show you another woman, same problem in just a moment. In fact, I showed this to her, and she said, I know how he feels. So two things that are very common that you notice about him. And first thing, by the way, you notice that if you ran into him on the street, you wouldn't think that anything was wrong. He's still very articulate at this stage. He's still very engaging at this stage. He looks very normal. And on the other hand, this changes later in the disease, as you know. So he said, number one, he was overwhelmed. So something that he could do before, he couldn't do at this point, and that's a common problem. And then the second thing, as I mentioned, is that he would get lost even on familiar streets. Now here you can see the second person. This guy was actually a big shot editor in Hollywood, and you can see if you ran into him on the street, you would know something is wrong. And so he's farther along here, and he's talking to his daughter.
Hey, Dad, what did you do for a living before you retired? Do you remember?
Yeah. I worked in Idaho.
Do you remember working in Hollywood?
Oh, yes.
And did you know that you were like a big shot editor in Hollywood? Do you remember that?
Yeah.
So he takes a strategy that many people take later in the disease, where they just say yes to things. And of course, if you dig down, there's nothing there. He doesn't know where he worked and who his friends were and so forth and so on. So if you look globally, there are approximately 30 million people with dementia, most with Alzheimer's disease. And in a paper in 2014, it's actually been pointed out that this has now become the third leading cause of death in the United States, after cardiovascular disease, number one, cancer, number two, dementia with Alzheimer's leading at number three. And that led President Obama to sign into law in 2011 the so-called NAPA, the National Alzheimer's Project Act. And we've now had 2 summits. And the problem with these is that we agree that yes, there is now for the first time in history a national plan for Alzheimer's disease in this country. The problem is there's no plan for cure. So we just keep continuing with let's get the next medicine, the next silver bullet, and these things of course have not succeeded. If you look out to 2050, number one, Medicare will have become broke. So Medicare will not succeed if we continue at the current rate with Alzheimer's disease on a purely financial basis. If you look globally, we're talking about 160 million patients. So something needs to be done between now and then. The NAPA, President Obama has called for us to have something that is, quote, 20% better than what we currently have by 2025. Well, for people who are getting Alzheimer's now, that is a long, long time. And as I show you today, we can do much, much better. And as you probably know, women are actually at the center of this epidemic. 65% of the patients, as you can see, and 60% of the caregivers. And in fact, if you're a woman, your chance throughout your life of getting Alzheimer's disease has now exceeded your chance of getting breast cancer. So a major problem. And actually, I just spoke, thanks to Alan Bortel, who's here. I spoke at Sacramento just 2 weeks ago before the California State Assembly Committee on Long-Term Care and Aging. And we talked about the very issue of how do we go about reducing dementia in the state of California. It's currently costing the U.S. over $200 billion a year, and the state of California over $25 billion a year. So it's a major problem. And as Julie indicated already, there are no cures right now. There's no medicine that your doctor can give you that will cure this illness. So major problem. So let's look at that. And if you just look at the things that are in trial, you see a couple things immediately. The first thing you see, every single thing that's in trial here is a monotherapy. Every single thing is a medicine. And this is despite the fact that even something as simple as HIV, which is much less complicated than Alzheimer's disease, it took 3 drugs, as you know, to be really successful with that one. So why are we continuing to pelt this disease with monotherapies when it really hasn't worked? The second thing you see is that there aren't that many different types. So these are color-coded here for the different groups of drugs, and there aren't that many different targets that people are working with. And the third thing you see, the ones with the asterisk here, with the ones that are going to disappear here, these have all already failed in the trials. And here are the ones that are approved, and as you know, minimal effect, and just fall into 2 different groups. So there are some major problems here. And if you just look at the last few years, you look at these, and look at these, every single one of these has failed in trials. This one, as an example, semaglutide. Lilly spent over $500 million developing this drug, and not only does it not make Alzheimer's better, it actually makes it worse. So there's something wrong when the best we can do is to make the disease worse. One man told me, the last thing I want to have is something that prolongs the illness. And all of these things that have been tested have been taking the curve, which is declining, and simply making the curve decline more slowly. And one man said to me, why would you want that? He said, that's the most horrible thing you can do. What we want is the curve to go up, right? We want the first derivative to be positive, not negative. And that's what I'll show you today. If you look at the last 10 years, by the way, 244 clinical trials, 243 failed outright. The one that succeeded was Namenda, which has an absolutely minimal effect. You can see this one, Dimebon here, failed once, they didn't believe it, they did another trial, failed again. So it's a real problem. So it's a sad state of affairs, as Julie indicated. If you're a patient, you don't often go to seek medical attention. You don't try to go in early. What you're trying to do is stay at your job. You're trying to continue to be engaged. You don't want someone to take your driver's license away. You don't want someone to send you to a nursing home. And you don't want someone to write in the chart memory problems. And I'll show you a woman written in the chart memory problems. She was then unable to get long-term care because of that one word written in her chart, memory. So this is a really negative situation. On the other hand, primary care providers, they don't tend to refer the patients. They say, well, look, I can write a prescription for Aricept. So what? That's easy. So often people don't really know what the cause. Do they have frontotemporal dementia? Do they have Lewy body dementia? Do they have vascular disease? Do they have Alzheimer's disease? Do they have SCI or MCI? What stage are they? Because they don't get referred. And then when they finally do refer them, which is unfortunately often late in the process, what do the specialists do? They say the same thing we heard, good luck with that. They say, well, we'd like to study you as you go downhill. We'd like you to come in for a spinal tap every 6 months. This doesn't help us. So this is a really sad state of affairs. So the question, and we started to address this 26 years ago when I set up the first lab, how do we go about developing an effective treatment for an incurable disease? So what we want to do is understand the most fundamental concepts. What is actually going on here? What does this disease represent at the most basic mechanistic molecular level? Because that will give us some clues about what we can do about it and what we can't do about it. So the idea here, we want to change the frame of reference. When you take an insoluble problem, you want to ask, maybe we should be attacking this in a different way than other people have been attacking it. So I want to show you a couple of patients here. I want to show you a woman. This actually got things started. I call her patient 0. She came in actually 3 years ago. And so what happened, we had proposed in 2011 exactly the sort of thing that I'm going to show you today. And it was the first trial for a comprehensive therapy for Alzheimer's disease. And this was actually submitted to an IRB, both the public and private IRBs in Australia. And they both turned it down and said, this is too complicated. This is not the way you treat a disease. You have to have a medicine and just have one medicine or no medicine. So we actually had a new medication, which we discovered here at the Buck Institute, which is called Progesterone, which, by the way, is now in a clinical trial in Australia. But the idea was we wanted to have a group, so it was double-blind, placebo-controlled. You have the placebo, you have the Progesterone. But then we wanted to have all the other changes with and without Progesterone. Then we get to see, does the drug work? Do the changes work? And what happens if you put them together? Maybe this is a really powerful way to get after this disease. So when we got turned down, there was actually a wonderful philanthropist who had been so wonderful to us over the years and so helpful. And he said, if you worked for me, I would fire you now. Because he was understandably disappointed about the fact that we couldn't get the IRBs in Australia to approve this trial. That, of course, we'd been telling him this is the greatest thing since sliced bread, which we still think it is. But at the time, we thought, well, how come we can't get the medical community to be interested in this? And the paradox, and these sorts of paradoxes, I'm sure Julie has seen this, they come up again and again and again. The physicians who were on the board, the IRB that turned it down, then turned around when we said, okay, well, we'll just do the drug alone. They said, we're very disappointed. We wanted you to do the whole thing. We said, what do you mean? You just turned it down. They said, yeah, well, we're wearing that hat, but we still want to see it done. So, this is the sort of thing that we run into again and again and again. We have to change the way we address these sorts of trials. So this is a woman actually who works for the US government, and she's living in Washington, D.C., and her mother had passed away from Alzheimer's disease and had gotten symptoms at the age of 62 and passed away in her early 80s. So it had been a horrible, very typical story. She'd gone to a nursing home, she couldn't remember the family's name, all that sort of stuff. And this woman at 65 began to have similar symptoms, and she was horrified. And specifically, she got lost on the freeway and things like that. So she went to her doctor and also put it off for about 2 years, went into her doctor, and he said, yes, you have the same thing that your mother did, and there's nothing I can do for you. And he wrote in the chart memory problems, and so she was unable to get long-term care. And so what happened was that she called a friend and said, I'm going to commit suicide. I watched what happened to my mother, and I now know I can't even get long-term care. I know my future, and I'm going to commit suicide. And her friend turned out to be someone who lives in San Francisco. And so she was nice enough to say, well, why don't you come to the Buck Institute, because I hear they're doing something new and different. Now, at that time, we had just sent this to the Australian IRBs. We'd just been turned down. I was very depressed. And I got this call, and I said, well, look, I haven't seen patients in 20 years. I've been in the lab working because we want to have something to offer. But I said, I'm happy to talk to her and tell her, what we call the 36 holes, what all the things are that we go through, all the things that we're going to adjust based on the theory I'll show you here in a moment. And so we spent 2.5 hours in my office going through my little laboratory office here, going through all these things. And I said, look, take this back to your physician if you want to try it. And I thought I would never hear from her again. 3 months later, I got a call on a Saturday morning at my home, and she said, I can't believe it. I'm back to normal. I'm back at work full time. She travels to Afghanistan, Iraq, all over the place, and just heard from her again last week, and she's been doing great. So very, very, very excited to see this. So, of course, when she came out again, I said, do you mind if I take a little movie of you? And she said, no problem, as long as you don't use my name. So I'll show you, and I'll show you the people actually that you'll see who are back at work are people who've had their faces pixelated or shaded specifically so that they can continue working. One physician who came in us last summer, a year ago, said, I want to come out and talk about how wonderful this is, but if I come out, my career will be over the next day. So he's continued to see his patients and do very, very well. And interestingly, a couple of these people have gone on and off the program for reasons that they were traveling or they ran out of things, etc. And they've gotten worse, and then they've gotten back on and gotten better, which really suggests that they're onto something. So this is a woman, as I mentioned, unable to navigate. She couldn't remember. She would say that, I'd start at the top of the page, I have to then read again from the top of the page. She couldn't prepare her reports for work, so she was going to have to give up on work. She had a retinal scan that actually showed that she had quite a bit of amyloid in her retina, so she has very classical Alzheimer's. And then she was treated with what we call MEND, metabolic enhancement for neurodegeneration. So this is when she came back, and I said, do you mind if I can have a little bit? So these are 2 short videos of her. A little bit about how things were a year ago.
Well, a year ago, I was having a lot of difficulty. I was very frustrated because my memory was poor. I had issues of being spatially disoriented, particularly when I was driving. I would get off the freeway, the wrong exit, or not know where I was getting back on unfamiliar routes. I would reach in my house for a light switch. I'd reach on the wrong wall, even though I always had the light switch was always been on the right side. I'd start reaching to the left. I call my animals a different name, my pets, and I was really worried about it. I was very stressed about it. So it was a very stressful time.
How things work?
I have a job that requires a lot of mental analysis, a lot of thinking. I do a lot of research. I have to collect data, design the study, and then do the analysis and write a report, usually under pressure. And I was finding that I just couldn't complete an assignment. I couldn't think about the analysis. It was just a jumble to me, and I would start procrastinating, putting it off, and the longer I put it off, the more stress I felt. So I was worried that I was not going to be able to continue with my career.
Tell me a little bit about how things are now.
Things are much improved now. My memory is much better. In fact, I wouldn't even go so far as to say I don't think that I have a problem with memory now, which is a great surprise to me from where I was a year ago. My thinking, cognitive ability, and ability to do work, ability to do reports, I am back into the stream of things, being productive and being able to do my analysis and writing, which is fantastic.
And how's the driving?
Driving, no problem. I drive at night, I drive at daytime. I know where to get off, where to get on. I'm on the highway, so I feel like that's wrong. I'm not reaching for the wrong side of the room for the light switch. I'm not calling my pets the wrong name, which I think you're probably grateful for.
And how overall are you feeling?
I feel great. I feel really, really good. I feel energetic. I feel more peaceful and calm about my life, but at the same time very enthusiastic. I even started writing my book.
Fantastic.
A couple of chapters.
Okay, thank you very much. So she has just turned 71 this month. She's now 6 years from when she started her symptoms at the age of 65, and she's doing great, still work full-time and doing extremely well. So I want to spend just a couple of minutes and want to show you how we can do better with this, how we can understand this illness, and how we can continue to push to do better and better and better later and later and later and more and more and more complete. And I want to spend a couple of minutes talking about ApoE4 because this is a critical issue. As you know, it is the most important genetic risk factor, as you've heard from Julie. And we have some very exciting new data to show us what is actually going on. Why is it that this is such an important risk factor for Alzheimer's disease? And I want to mention that this is the work of some scientists in the laboratory here, and Dr. Ramohan Rao, he's here. Ram, can you stand up? There's Ram in the back here. Thank you, Ram. And Dr. Veena Thimdakara. Veena, are you here? There's Veena in the back. Thank you, Veena. And Karen Pokse. Karen, are you here? Where's Karen? All right. Thank you, Karen. And then also Dr. Claire Peters-LeBur. Is Claire here today? Okay, and I know that Patricia Spillman is down at UCLA right now, and I know Vargas is down at UCLA, Vargas John. So there are many people who've contributed to this important work, but about 6 years ago now, we started an interesting project to ask that question. Why is it that ApoE4, what's going on here? Why don't we understand this? In the field, the dogma is because ApoE leads to a decrease in the clearance of the A-beta. The problem is that doesn't explain about 90% of what we already know about apolipoprotein E. So I call this the chimp that killed the rhino, because if you look, it's a very interesting phenomenon. If you look at human evolution, and for those of you who are in the Tea Party, I apologize, but if you look at, but for those of you who aren't, let me go forward on this. So if you look at human evolution, there's a small, relatively small number of genes that changed between the simians, the chimps, and the hominids, what became the humans. And in fact, that small number of genes includes prominently ApoE. ApoE4, there's an ApoE chimp, but there's an ApoE4 which is different. And in particular, threonine 61, a specific residue, became arginine 61. So there was a fundamental change in one amino acid that changed the shape of the ApoE. And as I'll show you, it changed its function in a very interesting way. So if you look and ask, well, what does ApoE do? Well, it's involved in evolution. It's an important one. And interestingly, the surprise is that the things that allowed us to become human were mostly pro-inflammatory. Why would that be? Why would you want inflammation? And the argument that's been made, and I think it's a really compelling one, by Tuck Finch down at USC, Tuck has pointed out that when we, as simians, came down and became hominids and came down out of the trees and we wandered on the savanna, what did we need? We were stepping on dung and getting infected. We needed something that was pro-inflammatory, anti-infectious. We started eating meat with microbes in it. We needed a way. In fact, we ate more meat. We got bigger brains. We got more fat. And so third, we fought each other over the meat. We ate less often. So what does ApoE4 do? It allows you to eat less often. It allows you to absorb lipids better. All these things, all this inflammatory effect helped us to come down out of the trees and onto the savanna. But after the age of 40 or 45 or so, it actually hurt us. So it's what's classically called antagonistic pleiotropy, because you now have a pro-inflammatory state. So it has an effect on evolution, on longevity. In fact, people with ApoE4 as a whole are underrepresented in centenarians. It, of course, is a risk factor for Alzheimer's disease. So we call this the God gene because it really was about a change in our evolution. So what happened with evolution? God came down and touched us with DNA here, made all the changes that allowed us to become humans, and allowed us to do the things that we couldn't do before. So it was really a tremendous, tremendous advance to have ApoE4. And in fact, you can see throughout all of human history, all that's been available to human species has been ApoE4 until a mere 220,000 years ago, when ApoE3 appeared, and of course now has become the dominant. But still, 75 million Americans carry ApoE4. And my hope is that following up in the months and years to come, we will be able to identify all those people and treat all of them so that we don't have to face Alzheimer's disease for the future. That's the goal. And then just here you can see in the last 80,000 years, ApoE2 appeared. So if you look at the structure, what you see here is that ApoE4 looks like columns. And here's this arginine 61 that changed from the chimp. And what it did was it created this interaction with glutamate 255. So it changed the shape of the molecule and changed its function. On the other hand, what happened later, 220,000 years ago, a second mutation appeared, which now made ApoE3, where cysteine 112 now interacted with this arginine, allowing this arm here now to move away. So now ApoE3 looks like a nutcracker, whereas ApoE4 looks like columns. So the project that we started several years ago with Ram and with Veena and with others was the idea, and with Karen and with everyone who's working on this, was the question, okay, we know what starts the problem, we know what's at the other end, what's in the middle, what's in that black box? And what Ram found was very, very exciting. And I'm going to summarize several years of work by Ram and Veena and others because it's been so exciting for me to see this. So ApoE is supposed to be something that carries lipid, and indeed that's what it does. It carries fats around. It's very important for that, and so you've heard about it with cardiovascular disease and things like that. But what Ram found, which really sets the whole field on its ear here, is that when ApoE binds to various receptors, and there are several receptors known for this, it enters the cell. Here's in the endosome, but then interestingly, it exits from the exosome. It interacts with a molecule called REL-A, which is part of NF-kappa B, which is a critical and large part of your pro-inflammatory cytokines, or pro-inflammatory mediators, I should say. It leads to cytokines increasing, but it's an important pro-inflammatory mediator. And then, here's the surprise, they go into the nucleus together, and they bind to 1,800 different gene promoters. So this now finally tells us why it is that you have this tremendous impact on evolution, on inflammation, on longevity, on cardiovascular disease, Alzheimer's. It really does fundamentally change the program in your cell. It's not just about less egress of your A beta. So big difference here. And so Ram has mapped, and with Veena has mapped all of these 1,800 promoters. And here's the exciting part. If you group these together, you literally could not write a better story for Alzheimer's disease. So it has to do with inflammation, and especially NF-kappa B. The genes that this binds to have to do with neurotrophins, supporting neurons, cell death, programmed cell death. Guess what? SIRT1, the very reason people take resveratrol, the red wine, that whole story, it binds to the promoter of SIRT1. What a surprise. Synaptic dysfunction, interestingly, glucose homeostasis, which is known to be related to Alzheimer's disease, microtubule disassembly. So what he found really gives a whole new look to where Alzheimer's comes from and why these changes when you have ApoE4. Great, well the more we know about these mechanisms, the more we can reverse them, the more we know what the targets are. So what this really says is, when you have an ApoE4 dominant system, that is a REL-A dominant system, because REL-A and SIRT1 actually are mutually antagonistic. So this is just like North Korea, South Korea. You can either take your resources and turn them into war, inflammation. And by the way, if you are living in a third world country in squalid conditions with poor food, you survive much better if you have ApoE4. But if you're in conditions where you're eating frequently and you're not in squalid conditions and you don't need to be in a pro-inflammatory state, then of course it can be a liability. On the other hand, if you have ApoE3, you are in a SIRT1 dominant situation where, just like if you're a country, you've got research going on, you've got a lot of recycling and so forth and so on. So it's two different cellular strategies. So, Louis XIV did very well by being bellicose and spending a lot of money. Of course, that didn't work out very well for Louis XVI and Marie Antoinette. So the idea here is we can take this and we can change this so that you act as you are aging in a more ApoE3 SIRT1 dominant situation. So I want to show you quickly then, why do neurons degenerate? This was the problem we started 25 years ago here. And so the idea is we're going to go back to the most fundamental aspects of this. When you want to build a human being, what do? You have a human being that starts with one cell, then you have to have proliferation, you have to have migration, and you have to have integration. And this is no different than if you want to build a company. You have to have the right number of people, go into the right place, talking to the right people. Now, if you're a lower species, like a worm, like a C. elegans worm that we work with here at the university, or at the institute, and at the university, then in fact you're going to go through these and then you're going to live a very short time. C. elegans live about 3 weeks or so, and then you're going to die. But if you're a higher species like a human, you get to use these same reparative processes for regeneration, and therefore you get to live theoretically 100 years instead of 3 weeks. Huge advantage. But in so doing, you create a lifelong need for balance in these systems. So we all are used to hearing about what happens when this spec goes out of balance, the proliferation part. We have oncogenes, we have tumor suppressor genes. These make more cells, these turn over the cells. Your cells are committing suicide. Your white blood cells are committing suicide at the rate of 1 million per 2 seconds. You're replacing those. So you have to have a beautiful balance in this system. And what happens when you go out and smoke too much, or you get exposed to chemical carcinogens, you can get out of balance here. And unfortunately, we call this the disease cancer. It's really an imbalance in this signaling. Well, nobody ever talks about the analogy between these and the migration and integration genes, and that's been, until recently, there's been no way to increase this, in other words, to select for it and amplify it. But what we discovered then is that there is this beautiful balance between genes involved in synaptic reorganization, literally forgetting memory. And we're all doing this all the time. We're actively forgetting the 7th song that played on the radio on the way to work yesterday. That's normal. But everybody with Alzheimer's disease is on the wrong side of this balance for years. So good, we can decrease this, we can increase this, we can restore the balance, especially early on. That's the goal, that's the way to derive this. So this is Rita Levi-Montalcini, who, by the way, just died about a year ago at the age of 105, so she's a great person for an aging institute. She won the Nobel Prize in 1986 for the trophic factor hypothesis. These are factors that keep your cells alive. And at the time, it was assumed that when you withdraw these and you watch the cells die, it was because they would just passively die away. And we actually discovered way back in 1993, this was on the front page of USA Today, it was in Science, it was the cover of the Atlanta Constitution. We got all sorts of feedback from this. A new kind of receptor, and I'll show you how it works, because we now believe it is critical to Alzheimer's disease. So her view was, you have your cell here inside and outside, the trophic factors bind to their receptor, and good things happen. And that if they don't get that, there's this passive death. And what we found was that, yes, she was half right. I unfortunately got to talk to her about this when she was in her early 90s. And so the idea was the trophic factors come in good, but if you take away those trophic factors, take away nerve growth factor or brain-derived neurotrophic factor, what we found is that these receptors actively induce this neurites to pull back and ultimately the induction of cell death. Now here's the surprising part. We thought, okay, well wait a minute. Is it possible that instead of just taking these away, is there something out there that is actually an anti? And I remember this because of when I was an undergrad, I had read about Dirac, who had the idea of the positron. He said, well, maybe there's something that's the opposite of the electron. So I thought, okay, maybe there's something that's the opposite of trophic factor. And guess what? The amyloid beta that collects in the brains of patients with Alzheimer's fulfills all the criteria to do exactly that. So it goes through the very mechanism that we've discovered years ago and tells the cell, okay, you're on the wrong side of the balance. And what we're now realizing is this is part of your brain's overall sense of what can I do? It's a little bit like what's called quorum sensing. It's a little bit like your accountant telling you you can afford a Chevy, but you can't afford a BMW. So you change your brain to fit what you can do. So, as you heard from Julie, you start changing your abilities. Okay, I'm going to add this. I'm going to take away the problems. I'm going to add things. Now, you start to be able to do more and more. You start to be able to keep more and more synapses. So, what we realized is Alzheimer's is no different than the other chronic illnesses. Osteoporosis, you have throughout your life. Osteoblasts and osteoclasts, these make bone, these take away. Imagine that for 20 years you had two sets of contractors at your house, and imagine that the ones that did the demolition always did extra because they were your friends, so they do more for you. And imagine that the ones that did the construction never showed up. Your house would be getting smaller and smaller. That's exactly what happens in osteoporosis, and that's exactly what happens in Alzheimer's disease. Cancer, we have the cytoblastic side exceeds the cytoclastic side because of smoking and all these different things that change the DNA. And what we realized is Alzheimer's is no different. The synaptoblastic signals are chronically exceeded by the synaptoclastic signals. And of course, ApoE4, we already heard from the fact that it affects NF-kappa B and SIRT1 reduction. And the synaptoclastic part is increased. So, okay, now we know the targets to go after. We have to ask, what contributes to that then? So there's this beautiful balance that you have throughout your life. As you get older, this arrow can get shorter and this arrow can get longer. And these things, this is a synapse here. You have 1 quadrillion of these in your brain. You have an incredible computer in your skull. And 10 to the 15th. And these are like marriages, so that you have courtship, you have commitment, you have talk, you have function and dysfunction. These things literally talk to each other. And unfortunately, you can have divorce. So you can have where this actually pulls away and searches for another partner, and if it doesn't find one, it commits suicide. So the good news is, okay, we know a lot about the biochemistry now, so we can change each of these things. So the big question became, how do we change these? And we realized, oh my gosh, so I've worked with a person who does connectomics. And this is just a part, this is actually a paper that's in press, it's coming out this month. And this is just a part of the overall connectome. But what is amazing about this, it says that your plasticity balance, that very balance I showed you between making memories and breaking memories and the forgetting side, turns out to have to do with many, many different molecules. It has to do with what your estrogen level is, what your progesterone level is, what your pregnenolone is, what your vitamin D is, what your omega-3 to omega-6 ratio is, your copper to zinc ratio. Dozens and dozens and dozens of things all play in to this important balance. And the surprise was when we said, well, where does this come from? This is a beautiful, beautiful structure. It's a beautiful function. It must have something to do with normalcy. Even though the disease doesn't look that way, the underlying physiology does. So we realized, in fact, that this looks like what's called the EMT. So there's a thing called the epithelial mesenchymal transition, which goes awry in cancer cells. Your body has the ability to go back and forth through two states. And these states, and it's no different than if you have a country here that is very organized, higher order structure, everybody works together, versus a bunch of nomads that are all on their own. And your body goes back and forth between this. And guess what? When you have an insult, head injury, trauma, free radicals, on and on and on, you break down, you go away from the higher order structure and you go toward this. And so this happens in malignancy, it also happens with fibrosing illnesses, and what we realized is it also happens with Alzheimer's disease. So as you can see, the metabolism changes that occur with the EMT also occur with Alzheimer's. The inflammation state, the SIR-T1 to NF-kappa B ratio, the reactive oxygen species, the cytoskeleton, the insulin signaling, and the intercellular junctions are lost. This is all part of the epithelial to mesenchymal transition. So what this means then in a very practical sense, and I always tell the patients, there are 36 holes. Imagine you had a roof with 36 holes in it. The drug company is giving you an excellent hole for an excellent way to patch one hole. Now, that's not to say that drugs aren't important. They're the dessert, they're not the entree. But they're absolutely going to be more and more important going forward. But the point is that we want to close all of these. That's when we'll see an effect, not when we simply close one. That's why we want to be able to do a trial that closes all of these and includes one drug. That's the way of the future. So what we're really saying is that there's a new kind of medicine that is afoot, and actually David Perlmutter is a good example of someone who practices this kind of medicine. We're really good as Western physicians. We know about DNA, we know about proteomics, we know about metabolomics, we know about computers and so forth and so on, but we're not very good at putting it all together. And in fact, there's unfortunately a lot of financial incentive not to put it together and to get one drug at a time and market one drug. On the other hand, the traditional Chinese physicians knew about treating the whole body. They understood the symphony. They didn't know anything about DNA or mechanistics. So what we need going forward is to bring these two together and to create a new kind of medicine, right? A new kind of physician who is able to do this. And so in fact, one of the things we're really excited about is to work with John Q. Walker and his colleagues, where they're allowing us now to use much larger data sets. So quickly I'll show you here, this is a person who's ApoE4 positive. This is a guy I started seeing December of 2013, an amazing guy who's 70-year-old, last year he's now 71. Heterozygote. He had a 12-year history of decline, and he talks a little bit about this. And he had a PET scan, very typical for Alzheimer's disease, reduced glucose utilization, temporal parietal cortex, and he had documented, just as Julie did, he had documented his own decline, and in fact had extensive neuropsych testing. His CVLT, the California Verbal Learning Test, which is typically abnormal in Alzheimer's, had gone from 84th percentile to 1. So he had very, very little memory, unable to remember, having trouble at work. One of the interesting things about him is that he had, for his life, he'd been able to look at columns of numbers and add them up really quickly in his head, and been able to, he'd talk to his accountants and say, oh, it's about $423,000, that sort of thing. He lost that with his Alzheimer's. He got it back on this program, and he talks a little bit about this. And interestingly, when he started to improve, his wife called me and she said, well, you're missing the most important thing here. And I said, what do you mean? She said, yeah, he's better. She said, but the most important thing is for 18 months before he started on this program, he had been accelerating in his decline, so he had really gone downhill. And she said, as soon as he started this, that completely stopped, and then he started regaining his abilities. So let's show this, and this was actually taken by Leah Hodnett, who's here. So thank you, Leah, for this. Nice.
Went to Oklahoma Gym, and I could not compare the combination. which is, as I know myself, that'd be very unusual. And I would meet with my accountant, say, and we would just toss out some numbers, and I would have the number faster than he could get to his computer usually. So things like that started to wane dramatically. Clearly, the math has come back. That's a real vegetable thing. I mean, I'm fast with math again. People I had met, maybe even taken to lunch, I did not know who they were. I mean, it's like a new encounter. And then afterwards they'd say, you actually know this person. So that's kind of which is really...
So he was actually shutting down his offices, and since he started on this, he's decided now to open another office. So he's doing very well. So this is just to show, and I realize it's impossible to see this, I apologize for that. So several years ago, I sat down and made a table. I said, look, if you had the perfect treatment for Alzheimer's, what would be all the molecular mechanisms you'd like to address? And this is just part of it. So, you know, you want to have decrease in A-beta production. You'd want to decrease the beta cleavage site, the gamma cleavage site. You'd want to increase the alpha cleavage. You want to decrease the oligomerization. You want to decrease phospho-tau. You can go on and on and on. You want to do all these things. So it doesn't really make sense to go after this with one silver bullet, although there may be some drugs that help a little bit. The idea is to address all of these things. And in fact, if you look at a person, so here's a person actually that came to see me about a year ago, who's a physician, brilliant, brilliant guy who went to a major university when he was 15 because he was a genius. He actually read the entire Harrison's book before, it was on the internal medicine, huge book, before he interviewed for medical school. So he would just be able to say, oh yeah, what you work on is page 328. So he was, you know, always kind of a smart aleck guy because he never forgot anything. And both of his parents, unfortunately, had passed away with dementia. He found out he was ApoE4 heterozygous, came in and has a positive amyloid scan, you know, the whole 9 yards, positive PET scan, abnormal neuropsych testing, so forth and so on. So I asked, well, you know, what about the metabolic status? Well, this guy's a physician, and he hadn't checked all these things. So you can see here, every one of these yellow things, abnormal. And everyone I see who has symptoms has between 10 and 25 abnormalities. So this guy is walking around with a CRP of 9.9, walking around with a vitamin D in the low 20s, you know, on and on and on and on and on. So, okay, we started him, and interestingly, he got much better. His wife called me and said, wow, you know, he's doing so much better. Then he started to go off and he said, you know, I don't really want to do this. It's not that easy. I think it's a key thing. You know, it's like a hard diet. You've got to have some commitment, just as you heard from Julie before. So guess what? His wife comes home and the car is in the driveway with the key in it running. And he's been inside for a while, working away, never realizing he'd left the car in the driveway. So now we have a health coach working with him, and he's now started to get better again. So, you know, we can't make you better if you don't want to be better. And this is just to finish up here and to illustrate a point that you don't give up after the first time. As Julie said, you keep tweaking. You want to keep making the system better. So again, it's a new kind of medicine. You are continually iterating to make things better. And this was a 55-year-old attorney, 4-year history of severe memory. I mean, she came to one of the people in the lab following a talk and said, "Can you please help me? I have no memory left." She would record conversations. She took her iPad with her everywhere, but then of course she forgot how to get into her iPad. So she could not keep anything. She was trying to learn Spanish for her job. She couldn't learn Spanish. Her kids actually started doing this thing where they had 5 fingers and 1 finger, and they said, yeah, this is Dad and the 4 kids, and this is you, always 3 paragraphs behind. So it was really, really tough for her. And she came in, and it took her, she got a little better at the beginning, then she got further, and then it was the 3rd shot that she really got much, much better. So back at work, learning new areas of law, learned Spanish. And interesting, she came in once and said, you know, I brought my iPad just out of habit, but I don't need it anymore. So she talks a little bit about this here.
I couldn't remember conversations that I had with my kids and my husband. I started having to refer to my calendar all the time. I had to rely on it or I forget appointments. My son showed me how to unlock my iPhone. And by the next day, I could not remember what he had shown me. So there was one particular moment when I knew my memory was improving, and that's I was out with my husband, and we were having a conversation, And I remembered names before he did. I actually corrected memory that he had, made minor corrections. I remembered it more vividly than he did. And that had not happened in years. So I think that's when I knew that my memory was really good.
Okay, so these are the first 10 patients, as Julie mentioned, and 9 of them showed some improvement. And again, the ones that went on and off would have problems when they got. So to finish up then, current medicine, we ask what, not why. We give single drugs, they have side effects, they have minimal efficacy for chronic illnesses. We treat after the symptoms appear. We focus on the disease, not the system. We have tiny data sets. We look at your sodium and your potassium. When I first went to UCLA, I asked the experts on Alzheimer's there, well, do you check all these things? They said, well, we wouldn't know what to do with it if we did check it. So no, we don't. We just tell them we have an untreatable illness. Detailed genetics, they don't look at your entire genome. There's a lack of success with chronic illness. We've had a tremendous lack of success with chronic illness, especially neurodegenerative illnesses. And everything is focused, all the epidemiology, all the trials are focused on these mono interventions. So the future, this is why I'm excited about what John Q. Walker and his group are doing at Muses, to work with large data sets. We should know when you come in, here's your entire genome. By the way, this is being done, as you probably know, increasingly with cancer now. People look at the cancer genome and the same genome from the person and say, what's driving your cancer? What we're doing is exactly the same. It's simply that we don't have a tumor to biopsy. So we have to get at what is driving your Alzheimer's or what is driving your pre-Alzheimer's in a different way through metabolomics, which is what we do. So we want to be able to focus on large data sets. We have a systems approach, not just a disease approach. We want to be able to include genomics, proteomics, epigenomics, microbiomics, all these things that we need to understand. Why are you in this state or why are you headed? The diagnosis is why do you have this, not just what do you have, why do you have it? It's about programs, that's the future, not just single drugs, but programs as platforms for those drugs. The drugs are very powerful, but you want to use them with the whole program. And physiological approaches mean fewer side effects. We want to have much earlier treatment, we want to have prevention, and we want to focus on a multivariable system. So we want to do many things and ask, did that help, as opposed to just one thing and ask if that helped. So just stop with me for a moment and think, what would a world with dementia rates slashed look like? Imagine that half the people who are now in nursing homes did not have to be in nursing homes. Imagine the difference that would make. We're there. This is the beginning, as Julie said, this is the beginning. And perhaps the last day of her life would not have been premature. Perhaps we wouldn't have had that suicide last year because we'd have people to continue to be able to function. So I want to thank everyone who's here today for being part of the solution to an incredibly important problem. Thank you very much. I appreciate that. And let me also say that I want to thank the people. There have been some people that have just been incredibly supportive. We would not be here without the activism, but we also would not be here without the support. And in particular, I want to thank Douglas and Ellen Rosenberg, who have just, we wouldn't be here without them. They have been tremendous over the years. They've been so helpful. They've helped us to develop the new therapeutics, which has been great. Yeah, that's not going to work. And let me thank also Stephen D. Bechtel Jr. He and his foundation have been tremendous over the years, have supported this work over the years. Dagmar and David Dolby have also been supportive, and many others. And anyone who has supported the Buck Institute, thank you from the bottom of my heart. We would not be doing this without you.
But I'm guessing there's folks who have questions, so come on up to the microphone. I know we're not going to be able to get to everybody, but if you want to come up and ask a question, go for it.
Is this going to work? Why
don't you holler loud?
Yeah.
Doctor.
Yeah.
Judy Campese talking about chronic inflammation coming from the toxins released by senescent cells. It's noted, apparently, particularly IL-6, interleukin-6, which can be good for us or bad for us. It's interesting stuff. But can you tie her work in with your work?
So absolutely, that's a great intro. So there are many reasons for inflammation, including dietary, including eating sugars, eating the bad fats instead of good fats, including exposures. And by the way, what Ram found was that when you express ApoE4, your IL-6 goes up 20-fold. So there's a huge effect on IL-6. And what Judy Campisi's exciting work has pointed out is that as cells become senescent, they liberate, as you said, factors that increase this inflammation. So that is one source of inflammation. And as you know, there are efforts underway to develop drugs that would destroy the senescent cells and leave the good cells. So that's one strategy that we would hope we want to be able to add now and continue to optimize this program so that we get more and more ability to get rid of the bad side and focus and increase and enhance the good side. So yeah, these I think are very, very much related.
Your question?
Yes.
Anybody else have any questions?
Yes. This isn't all on yet, but I'll give it a try. Now, the decline is happening rapidly now, and one is feeling desperate. Where in California or nationwide can we go for some specific help for us, to analyze our particular issues?
This is a very good question, and I get emails every single day from around the world. I got one last night from Israel, actually. I got one yesterday from Maine. Where do I go? Where's the doctor who practices this? And I have to say, since, as you can understand, this came from 26 years in the test tube, so the infrastructure is not there yet. There is no such thing as going to your doctor and say, I want MEND therapy. It's coming, and as I mentioned, we're working with the software group to make this so that the doctors can access this, so that they can use this sort of protocol, and we're doing it as quickly as we can. So it's happening. If it's something there that is, that there's someone right now, and that you think that they would be appropriate, send me an email, and I'll get you directed in the right direction. Okay, you're welcome.
So let's try to turn this on.
Yeah. Yeah. Maybe, yeah, if you turn this one off, maybe.
Dr. Bredesen, what would you recommend for a woman in her early 50s that has been recently diagnosed with early onset? What steps would you recommend?
And how far along?
She was diagnosed in November.
And in terms of SCI, MCI, or Alzheimer's? In other words, is she able to drive? He or she is a woman, you said. So is she able to drive? Is she able to do things? Okay. So and neuropsych tests normal or abnormal?
Abnormal.
Okay. And has the diagnosis of MCI been made? Mild cognitive impairment?
Yes.
Okay. So this is the pre-Alzheimer condition, and this is, of course, this can be due to Alzheimer's-related pathophysiology or non. Is this, has there been either a spinal tap or an amyloid PET scan, anything to show that, yes, this is amyloid-related?
Correct.
Okay. All right. So, and ApoE4 positive, negative?
I'm sorry, I don't know.
Don't know. Okay. So yeah. So then so MCI is something that means this has been present, the underlying problem, for something like 15 years, give or take. Could be a little longer, could be a little shorter, but kind of that ballpark. And there can be several more years before the progression. And some people don't progress from MCI to Alzheimer's, but especially if it's amnestic MCI, where memory is one of the issues, it's more likely to progress. And so, yeah, I would recommend that this person talk to Julie or do the sorts of things that Julie has talked to you about earlier and the sorts of things that we're doing here. And again, if you want to drop me an email, I'll get her pointed in the right direction.
Thank you very much.
You're,
I'll get Julie's information.
Yeah.
Thank you.
You're welcome. Okay, I think we've all been here long enough, so it may, oh yes ma'am, okay. So, yes.
Phosphatidylserine.
Yes.
100. It wasn't in your journal article.
Yeah, So, and that's one of the things, and I think, we're continually evolve. So what I published was System 1.0. Now we're going to System 2.0, and then also System 1.0 for Parkinson's and Lewy body and things like that. So, yes, phosphatidylserine is part of System 2.0. It's a reasonable thing. I think many people use things like acetylcholine and omega-3s because there was so much evidence published by Dr. Wertman from MIT over the years showing that not only do you need to give the signals that say to your brain, build these synapses, but you need to give the building blocks. And the building blocks include acetylcholine and omega-3s. They are critical building blocks for making these synapses. Now, you've got to have the right hormonal milieu, you've got to have the right vitamin D status, you've got to have the right decrease in inflammation. You've probably heard about the resolvins recently. This is going to be another big thing coming out from Charlie Sirhan at Harvard. Resolvins and maresins are things that help you to resolve inflammation. So it's one of the big problems that we as Americans fight is that many of us have this chronic, incompletely resolved inflammatory state, which contributes to heart disease, Alzheimer's disease, and cancer.
So one final question
Okay.
from you, sir? No question there? Okay, well, all right,
Okay.
that's it.
Okay.
Can you talk about the retinal test? And
Yes.
might that be available?
Right. That's a really good point. So we've just actually done the first few people, and I think this is going to be a very helpful test going forward. It should be commercially available in 2016. This was started by a group called Neurovision. It actually originally came out of Cedars in LA. Keith Black and Steve Verduner and their colleagues. And what they have done, they've done a trial in Australia where they've compared the sensitivity of the retinal imaging to the sensitivity of amyloid PET scans. And there are a couple of things that are really interesting there. Number one, it turned out the retinal scans are a little more sensitive than the brain, which is not too surprising because the brain, you're really looking at much bigger lakes of amyloid. These guys are able to see tiny, we're talking about 20 microns, 3 red blood cells across, plaques in the retina, so it's more sensitive. Number two, that means it's likely to be more dynamic, so that we're now going back to the people that had the original ones who've now been on this program. Can we get rid of the retinal amyloid? We'll know in a few months. They're coming back. The first ones were imaged January 27th. The third thing, which I'm very excited about, is when you do an amyloid PET scan of the brain, you can't differentiate between parenchymal amyloid and vascular amyloid. And so for a small number of people, and this is especially concerning for males who are ApoE4 homozygous, occasionally they will have leakage through the vessels and actually have a hemorrhagic stroke. And so we are concerned about putting them on all these things that change things like omega-3s, that change the blood clotting ability. For everybody else, it's great. For those people, well, now when you look at their amyloid PET scans, you can't tell the difference. When you look at their retinal scans, you can see if it's in the vessels. So my hope is that we'll be able to prevent the problems that occur occasionally in these men, especially men more than women, with these hemorrhagic strokes. Of course, it's also important to ask, is that in the family history? Are there a lot of hemorrhagic strokes?